Examples of first order partial derivative. This one is the second example. If you are given u equal to e raised to x cos y, we have to find d by u by x and d by u by y. To find d by u by x, we keep cos y as a constant and derivative of e to the power x, that is e to the power x itself, and then d by u by x is e to the power x cos y. Now to find d by u by y, we keep the function of x as a constant and we differentiate the function of y, that is cos y. Derivative of cos y is minus sin y, and therefore d by u by y is minus e to the power x sin y. Next example is u equal to tan inverse x by y. As we know that d by dx of tan inverse x is 1 upon 1 plus x square. Here at the place of x we have x by y. So applying the same formula or linear differential equation, d by y is equal to 1 upon 1 plus x by y whole square. But as u is the function of both x and y, in our function x by y, again we differentiate with respect to x only. And if we differentiate x with respect to x, y will be treated as a constant and derivative of x is 1. So our differentiation will be y square here we multiply with 1 and we get y square upon y square plus x square into x by derivative of x by y is 1 by 1. And we get the result y upon y square plus x square. Again, if you differentiate the same tan inverse x by y with respect to y, again tan inverse is the function of x by y. So applying the same formula, we replace x by x by y. That is 1 upon 1 plus x by y whole square into inner part of the function, that is x by y. We again differentiate with respect to y and we get derivative of y, that is 1 upon derivative of 1 upon y is minus 1 upon y square and we get minus x upon y square. So after simplification, we get minus x upon y square plus x square. So these are the examples of first order partial derivative. Next one is higher order derivative. Higher order derivative we define by d by square z by d by x square, d by square z by d by y square, d by square z by d by x d by y, and d by square z by d by y d by x. To find these derivatives, what is the procedure? D by square z by d by x square we find by differentiating d by z by d by x again with respect to x. D by square z by d by square y square we find by differentiating d by z by d by y again with respect to y. To find d by square z by d by x d by y, we differentiate d by z by d by y again with respect to x. And last one, to find d by square z by d by x, we differentiate d by z by d by x again with respect to y. As you all can see, when we go for solving problems, we see d by square z by d by x d by y, this is equal to d by square z by d by y d by x. Now we find the higher order derivative using examples. Now examples. Suppose we have given the problem u equal to x square plus y square. Here we use the partial derivative because u is the function of two variables x and y. But when we go for derivative, when we differentiate with respect to x, y will be treated as a constant, and when we differentiate with respect to y, x will be treated as a constant. So to find all the 5 derivatives, first one, find d by u by dx. So when we find derivative of u with respect to x, we keep the terms of y constant, which they will remain as it is at their place. So x square ka derivative will be 2x, y square will be as it is. So this result is 2x y square. Now d by u by d by y, that is x square will be treated as a constant, derivative of y square is 2y, so result is 2x square. So next one here, to find d by square equal to d by x square, as I told you all, to differentiate first derivative again with respect to x, means d by x of d by u by dx. Put the value of d by u by x, that is 2xy square. Now, since we have to differentiate with respect to x, 2 will be constant, y square will be constant, derivative of x is 1 and it will be 2y square. Next, dy square by dy by square, that is dy by dy of dy by dy. Put the value of dy by dy, that is 2x square 1. Now 2 is constant, x square is constant, derivative of y is 1 and we get the result 2x square. Next one to find dy square by dy by x we differentiate dy by dy with respect to x. Put the value of dy by dy, that is 2x square 1, keeping 2 constant, y constant. Derivative of x square is 2x, 2 to the 4. Now last one, dy square by dy by x, we differentiate dy by dy x with respect to y. Put the value of dy by dy, that is 2xy square, and we differentiate with respect to y, that is 2y, 2 to the 4, 4x square. As you all see, keep these two derivatives, that derivative of u with respect to xy as well as derivative of u with respect to y, both are equal. So these are the examples based on higher order derivatives, partial. Next one is composite function. What do you mean by composite function? If u is the function of two variables x and y, that is u is related to x and y, and x and y individually they are related to another function t, then u is said to be composite function of t. And by chain diagram, it can be represented as u is the function of x and y, and xy is the function of t. Then u will be related with respect to t as a composite function. So to find du by dt, why we have written t here? Because u is the function of single variable t. Here I have written single variable. Whenever there is a single variable, always we write d, and when there are two or more than two variables, always we write derivative. So derivative of u with respect to t, how we get? First we find the derivative of u with respect to x, dy by u by dx, into derivative of x with respect to t, u to x, x to t, that is dy by u by dy, dx by dt. First part, in between the two branches, we have to put plus sign, and u derivative of u with respect to y